Hi, my name is Alexa Taylor, and for my 475 research paper, I chose to do the evolution of the human brain. The human brain. Has tripled in size over the span of about 7 million years. The body size to brain size ratio is crazy big. So the bigger the body, the bigger the brain. Emma Schankner wrote, humans are known for sporting big brains. On average, the size of primates' brains is nearly double what is expected for mammals of the same body size. Across nearly 7 million years, the human brain size has tripled, with most of this growth occurring in the past 2 million years. For the first two-thirds of our history, the size of our ancestors' brains was within the range of those of other apes living today. So, intelligence in the brain. Some people correlate a bigger brain meaning higher intelligence, but that's not true. There's been no correlation found that will prove that. It is found that the bigger brain of humans has resulted in higher mental abilities and higher productions, which means that modern-day humans have a higher chance of figuring out more difficult concepts than ancient humans would. This explains how the world has come up with more inventions and technology in the last 300 years than the entire rest of the time put together. Intelligence is defined as one's learning ability. It is how fast and how well the brain retains information using different strategies. As humans living in this era, we have greater potential to become more intelligent, but the size of our brain does not correlate with being intelligent. The intelligence gene is actually passed genetically. So it has been found that intelligence is 75% genetic and 25% environmental. And the ADRB2 gene is a gene that encodes for intelligence. A SNP of that gene is the RS1042713. This SNP of this gene will either show the arginine amino acid or the glycine amino acid. Depending on this, will tell whether one has the intelligence gene or not. The arginine amino acid does not code for the intelligence gene, while the glycine encodes for the intelligence gene. Today, there are more people than it used to be that have this arginine amino acid. Natural selection is taking place with this intelligence gene so that more and more people can be intelligent and be able to figure out different concepts. But the other 25% of intelligence is environmental. And so this means school and social groups. So depending on what kind of school, if they gave you a better education or the kind of people you hang around, it will tell for the other 25% of your intelligence. And so more people are gaining intelligence because of this genetic gene. So brains in comparison, when you look at to the picture at the right, you can see the bottlenose dolphin brain and then the human brain, the chimpanzee, the monkey brain, and the rat brain. And so you can tell from this that the human brain is pretty big when you compare all of them together. If you look at the size of the dolphin brain, a bottlenose dolphin weighs about 1,400 pounds. And so when you look at the human brain and dolphin brain in comparison, you can see how much bigger our brain is for our body size compared to the bottlenose dolphin. It is actually said that primates' brains are double than what it's expected to be. And so we can see here that our brain is 4 times the size of a chimpanzee's brain, 15 times as large as the mouse. And humans are a lot smarter than other animals. And one theory states that this reason is because our brains are able to communicate with others. And this is one of the biggest things that sets us apart from other animals. So the evolution of our brain, through the study of fossils and ancient humans, we have found that humans in the Pliocene time around 23 million years ago to 5.3 million years ago have had about 3 times smaller brain than modern humans. So if the modern human brain weighs about 3 pounds, that means that their brain only weighed about 1 pound. And so the Homo sapiens in the Pliocene time also had much smaller body size. And so it's been found that a direct correlation between body size and human size has been shown. So as you can see, the bottom brain is a pan-troglodyte brain. And we've learned this past semester that that's our most common relative, otherwise known as the modern chimpanzee. And so you can just compare the difference between these two sizes and to understand how much natural selection and evolution has changed between our closest ancestor to what our brain size is now. And so this is just a quick picture of the evolution of the human brain. And as you can see that as we started here, we had a smaller brain, and as we've grown, not only the brain size has increased, but the body size has also increased throughout time. And so this is kind of funny, I thought. When you think of like genetic differences in the brain, you can think about how the male and female brain works, and they're so different from each other. So you can think about, if a girl wants to go and get a pair of jeans and they go all across the mall to find these one pair of jeans, and this picture depicts that it takes 3 hours and 26 minutes, and then the male gets it done in 6 minutes because he goes just right to the store he needs and to exactly what he needs. But how our brain works and is wired actually entails a lot more than just shopping. So the formation of the human brain, CSIRO Oxford Journal did a study on the brains of 30 children ages range between 7 and 11 years old. And they found that these ages, the brain mass was already at 95% of their full brain volume. But the female brain only showed to be on average of 23% of their full volume. It is found that males had more white matter in their brain compared to females. The study showed that the female brain and structures like the cerebellum and the hippocampus were larger than the average adult structure. And many boys in the same study showed that most of their brain parts were larger than the normal adult brain. So somehow these parts must shrink before adulthood. And it is thought that the reason why they grow bigger and then they shrink is because it protects the brain from developing different kinds of brain disorders like depression. And also hormones play a big part in the brain for different male and females. So you think about even when you were we were a fetus, there was testosterone spikes at certain places or to create a male, and then same with female. But it's same with puberty. Our body will release more estrogen or testosterone as we're going through puberty to help us pubate. And then another thing is menstruation and child labor, that our brain will release to the pituitary glands different things to prepare us for women for child labor or from menstruation. And so that's how the formation of the human brain is different between males and females. And so some different brain disorders. It has been proven that women are 2 or 3 times more likely to experience depression because of the role of estrogen in mood swings than men. But there's a lot more to the developing brain than that. Brain disorders are increasing throughout time, but these mental disorders are not very well understood. There is strong evidence to conclude that brain disorders can be linked to a person's diet. So nutrition plays a huge role in this. For example, omega-3 fatty acids, vitamin Bs, lack of GMOs are crucial to not having mental problems. Most people get confused because they believe that omega-3 and omega-6 fatty acids are pretty much the same. Humans are supposed to have a 1-to-1 ratio of these two things, but in the United States, we're receiving about a 1-to-25 ratio. And so this is hurting the people's function of the brain. And so that's why we've seen such an increase in different brain diseases and brain disorders than there used to be. Vitamin B omega-3 are usually found in sea animals like fish and crabs. Animals that are not farm-fed are high in omega-3. So some examples of different diseases is that could be linked to the diet people have is Alzheimer's disease, memory loss, numbness to extremities, visual problems, and gait or abnormalities. And so this is because the brain isn't healthy enough and it isn't getting the things that it needs to do its job. And so the nutrition deficiency is in the brain. And so throughout time, our bodies have tried to compensate for not having these brain deficiencies. And so it's been changing itself and growing bigger as we're younger so that we'll have less problems with brain disorders, but it's still an ongoing problem. The last thing I wanted to talk about was climate. And so when you think of climate, I always wondered, like, how would that affect our brain, you know? But all over the world, there's people with different body sizes and styles. And so you'll have tall and skinny, short and fat kind of thing. And it is found that the short and stocky body types are found actually in cooler places around the world. And so this allows them to retain the heat more inside their body. And tall and lengthy humans are found in hotter regions because they do not retain heat as well. And so since there's a direct correlation between the height and brain size in human bodies, we can see that correlation in larger bodies. And so where it's hotter, you'll see taller people with bigger brains because they need to stay cool. Or where it's cooler, you'll see shorter people with smaller brains because they need to stay warmer. And so climate actually plays a big role in determining whether the brain size affects it. And so this being said, genetics and survival of the fittest play a large role in the size of the brain. The body size is largely due to genetics, but the environment still plays a small role in some physical characteristics. And that's all I have. There's my works cited page, and there's my works cited for pictures. Thank you.